Hi, I'm Boyd. I own a 49-foot sailing boat, and I also own a couple of 3D printers and wanted to explain how I use CAD design and 3D printing in my boat ownership. I would point out at the start that my original Ultimaker printer was given to me for my work as an orthopaedic surgeon by Ultimaker, and I have no contractual agreement with them to promote their printer or products. So what did I used to do before I retired? Well, I was an upper limb orthopaedic surgeon, and I commonly had to fix fractures which looked like this before and after, and sometimes very small bits in the finger. I then started using 3D printing to convert CT scans to 3D models to help me visualize fractures prior to surgery. This is just an example of the upper end of the humerus. This is a little plate put on the elbow, which I could practice prior to operating. Many of you will be familiar with manufacture of things, starting off with a lot of something and taking bits away till you end up with the bit you want, which in some ways is called reductive manufacture. This is a Myford lathe. This is a CNC, so computer-controlled milling machine. And again, you're starting off with a lump of something and taking stuff away to produce whatever it is you want. Finally, this is a laser cutter, which you can accurately cut various materials, but you always start with a large bit of something. The opposite is additive manufacture, and that's what is colloquially known as 3D printing. There are various different forms. You can start with a powder and a laser beam, and that is called SLS. There are other things called binder jetting, direct expansion, etc., etc. None of these really are what I do. So what I've got is a 3D printer made by Ultimaker. In fact, I have two. I have a standard size one and a little one, which I'm shortly to put on the boat. The cost of the standard size one is just over £3,000, and if you made something as big as it could be, it would be about 20 something centimeters square, but would take a very long time to print. The little Ultimaker to go, it makes most things about 12 centimeters square. So here are my two 3D printers. The one on the left is about 30 centimeters cubed, and the one on the right is about 20 centimeters cubed. People commonly ask, how does it work and what do you start with? So you start with a filament on a reel, and the filament is 2.85 millimeters in diameter. The easiest stuff to print is PLA, which is polylactic acid, which is a biodegradable form of starch. It prints at a slightly lower temperature and it's easy to work with. The other material that I use commonly is ASA, and I use this because it is ultraviolet resistant and very stable to heat, but it is a little harder to print. Other people use ABS, but it isn't ultraviolet resistant, and so I tend not to use it. The material comes on a reel, and this is black and this is ASA. This is a flexible white material, so it's slightly softer and bendy when it's printed. This is just white PLA plastic on a reel. You can get PLA when impregnated with woody type stuff to make a wood appearance, and it actually smells like burning wood when you print it. There is a PVA, which you'll know is a glue, and you can use this in one of the printers to make supports, which then wash away after you've made the material. The filament is loaded from the back of the machine, and the reel is either on the back of the machine, or in this case I have two reels going into the machine, so one is off to the side. The material then goes up through this clear plastic tube, as you can see, that goes over the top of the machine and enters the print head. The material comes out a print head. The print head has a hole in it, and I commonly use a 0.4mm hole, and the print head is heated to melt the material as it is extruded. So PLA I tend to print at around 210 degrees, and ASA needs to be hotter, and I generally print that around 245. The print is formed on a print bed. The original printer came with a glass bed, but that makes getting the components off a little tricky, and I've moved over to having a flexible, removable bed, and at the moment I'm using one made by a company called Zyflex, as you can see. And the print head stays in the same horizontal level, and the print bed drops down as the printer prints. So here you can see the print head moving around, making the shape in blue, and once it's done all of the passes at that horizontal level, the print bed moves down so that the next level can be built up. And the other thing to note is on the bits on the side which aren't touching the build plate, you have to have supports, because obviously you can't print in fresh air. And eventually the model is completed, and there you have the completed thing. Covers for the instruments. So where do you get the design of what to print? Well, you can print things that other people have designed. So there's a very good website called Thingiverse where people post their own designs, and you can import them and use either all of the design, or in some cases just part of the design if it's something particular, such as the threads that I needed for a hose adapter. You don't have to have your own 3D printer. You can use a commercial company to print the design that you've made. So here's an instrument cover that I designed, and if I wanted to get this company to print it out, it would cost around £51, not cheap. So let's look at the terminology. There are various terms bandied around that you need to understand. First is CAD, which is Computer Aided Design, which is the software that I use to create the virtual model of the widget that I need. It's saved in a format that the next bit of software can understand, and that is a bit like JPEG. It's called STL, and I think it stands for stereolithography, or maybe standard tessellation language. Doesn't really matter. Once you have your model, you have to put it through some software to make the computer code that tells the printer exactly how to print, and that is the G code. So what do I use to make the model? Well, there is some very powerful software made by one of the big manufacturers, and it's called Fusion 360, which if you were to buy it is £438 a year. But fortunately, you can use it as a independent modeler. So I use it for personal and hobby use, and I just have to keep refreshing my license every couple of years. Once you've got your model, you need to get software that will slice it to tell the machine what to do. So you're going from STL to G code, and Ultimaker, the people who make the machine, have open source software called Cura, and that takes the STL files, converts them to the instructions on G code, and then you put that in the printer or send it to it wirelessly. This bit of software is free, it's open source, and actually can run lots of different printers, not just Ultimaker. And it has a lot of configurations to improve and enhance the prints. So here's how to use Fusion 360. You can make things. So you can make a sketch and you make a design in one plane. Here I'm just going to make a little rectangle to show what happens. And so this is your initial plane. Once you've made your rectangle, you can extrude it or enlarge it. And so this is the button to extrude. You say I want to make it into a box. So you can just pull it up. So I just do that again. There's a little arrow, and here we are. Now I've got a box. And then you save it, and hey presto. And if you want to go back and change any of the dimensions, it's very easy to do. And this is just how I would make a box that's got walls and isn't solid, for example. So once you've done it a few times, it becomes quite easy to do the steps again. lighting, and also a little Arduino, so I've made a box to hold my barometer that I created. Here we have a knife held in a knife holder, and here I've printed in ASA because it's outdoors, and this one has been strapped to the wheel for about 4 years now and hasn't. The cutlery drawer was a bit of a mess, so I've made dividers in the woody material to hold the various different size bits of cutlery. I made a cover for the speakers, since the loudspeakers tend to degrade and I had to replace them every few years, and although they're not perfect, these covers are designed to be on the speaker when we're not on the boat, so I wasn't too fussed about redoing it. As I've shown before, you can make covers for the instruments. These I made for a friend who had lost them, and I was able to put the name of the boat on, which I thought was neat. Here I've made some covers for the bottle screws rather than repeatedly taping them up, which I found a bit of a pain in it. Batteries always tend to roll around, so I've made a series of boxes to keep the batteries nice and neat. I have written all of this up a few years ago in Practical Boat Owner, but admittedly that is now a little out of date since I've changed software and also changed printers. So I hope you found this helpful. If you've got any questions, please feel free to email me. Bye.